In this brief video, we're going to talk about dispersion, which is, well, it's a kind of special case of refraction. So as we can remember, so far we've looked at reflection in the first video, then we looked at refraction, and as part of that, total internal reflection. That was in video 2. And then in video 3, we looked at lenses. So in this video, video 4, we're going to look at dispersion, and particularly this syllabus point shown here. So you need to give a qualitative account of the dispersion of light by the action of light on light of a glass prism, and including the 7 colours of the spectrum. And you may even notice this cool coloured pen I've used has something to do with that. In fact, there it is. That's got something to do with the visible spectrum, which we'll find out about. So, what do you need to know? Well, it says through a prism. First of all, what is a prism? Well, it's just a triangular block of glass that looks something like that. And you can see one down here. Now, when white light is shone on that, you see the white light coming in from here. So when white light is shone onto the glass prism at an angle so that it does refraction. So if you shine it in on the normal, so if I draw the normal into the surface there, if I shine the light in through there, you won't see this effect because they all slow down together and there's no observable bending. So it's got to be at an angle to the normal like that. The greater the angle, the more you're going to see this. Now what you notice is as the light enters the prism over here, the different colours bend by different amounts. Now, if it didn't bend at all, the light will just continue in a straight line. That's a bit confusing because I'm going to have to use a blue pen here. I'm not referring to blue light, I'm just referring to white light. It will continue in that direction. But what you notice is that the light is being bent. Now, which one's bent the least? Well, red, you can see, is bent the least. And blue, well, I should say violet really, is bent the most. The reason being is that they have different refractive indexes in the glass. Remember, the higher the refractive index, the more they bend. So red has a lower N in glass. Blue bends more, so it has a higher refractive index. Only slightly higher, but enough to cause this effect called dispersion. The colours in between all have values in between these two, and that's why they appear in between. Now, what order do we get here? Well, you might remember good old Roy G. Biv. Now, what's that got to do with this? Well, Roy G. Biv, great physics student, because he never forgot this. R stands for red, O for orange, Y for yellow, G for green, B for blue, I for indigo, V for violet. That's the order that we see the visible spectrum. Remember, it's just a tiny part of the electromagnetic spectrum. Watch my next video if you're not sure what that's all about. So red's up here, going all the way down to violet at the bottom here. So when I say blue, you should really put violet in there. I should add it up here actually why they have a lower N. Well, that's because light, because of the degree of which the red and the blue light slow down when they enter the glass spot. The red light slows down less, so V reduces by less than the blue light. The blue light velocity slows down more, hence more bending, and that's related to the refractive index. Remember, refractive index tells you how much the light slows down by, and therefore how much it's going to bend by. And you can see in this lovely animation what we're talking about. You see how the white light is splitting up into its separate parts here. So red, orange, yellow, green, blue, indigo, violet. Red bends the least because it slows down the least. Violet bends the most. Also, you can even see they've done this so well. You see the difference in wavelengths. You can see that red has a longer wavelength than violet or blue. You need to remember that. In fact, violet or blue has a higher energy, remember, and that's why it damages your eye. Now, is there anything actually appearing down this part? Well, there is, but we just can't see it. Violet, or beyond violet, which is called ultraviolet, that's where the name comes from, ultraviolet. Down here would appear ultraviolet, if you could see ultraviolet. And as you probably guessed now, well, what's the other part that comes above this? Well, it's going to be infrared. Infrared would appear here. So actually, sometimes you get a question, where would it be the warmest, or where would a thermometer increase by the most? Well, it's going to be in this region, because remember, infrared is related to how warm an object is. So infrared would be up here, but again, we just can't see it with our eyes. So just to add that into our spectrum here, infrared, as we said, would appear just above red, and it's not that hard to remember that because if you think about it, the clues in the name, infrared, is going to be near the red. Likewise, ultraviolet would appear down here. Again, clues in the name, ultraviolet, it's going to be near the violet end, so you don't really necessarily need to remember that. Hope you found this quick 5-minute video useful. In the next one, we're going to talk about the electromagnetic spectrum.